All right, first of all, what is Hooke's law? See if you can write it down. Now, if we have a mass on a spring and we extend that spring, we keep adding, we call it weight, through an extension x and plot the graph of force versus x, we get a straight line for a large portion of that spring. And Hooke's law is F is kx, or F equals negative kx. The negative only means restoring force. Now, what is the k? It is the slope of the graph, the spring constant. Very important. How much energy is stored in a compressed spring? Well, if we plot force versus the extension, we get a straight line graph. That's force versus distance. The area under a force versus distance graph is the work done. That would be the work done to extend or compress the spring, which would be the energy stored in the spring, 1/2 kx squared. K is the spring constant, x is the extension. Make sure you have that memorized. Easy marks. What is the period of a mass on a spring? Memorize this formula. And there it is. K is the spring constant. And remember that T is proportional to root m. That might be useful. Next, what is the period of a pendulum? Make sure you memorize this one. And the answer is T equals root L over G. Now in the 70 multiple choice questions, use 10 for G. And remember that T is proportional to L, root L. And if they asked you for the period on another planet, just find out what G is on that planet, the period of a pendulum. What is the useful energy formula for a simple harmonic oscillator? Well, all right, we have a mass in a spring, and there is the equilibrium position. I started vibrating, and it goes up and down, and that bottom arrow is the maximum extension at the bottom equals the maximum extension on top. As it passes the equilibrium position, all the energy is 1/2 mv squared. At the maximum extension, which we called A, the amplitude, it's 1/2 Ka squared, K being the spring constant. I set those two equal to each other. 1/2 mv squared equals 1/2 Ka squared. Make sure you know how to do that. What is the relationship between period and frequency? This should be at the tip of the tongue. T equals 1 over F, and F equals 1 over T. Excellent. Now let's briefly review concave mirrors. Now, this is a concave or parabolic mirror, and that's called the principal axis. And the point where all the light is focused that comes in parallel to that principal axis is called the focus. And the distance from that point to the mirror is the focal length. Twice the focus away is called the center of curvature. Now I will show you how we can draw and find the image of one object. We use two rays. One goes parallel to the principal axis, then through the focus. Another goes through the focus and then parallel to the principal axis backwards. We reconstruct the image there. Now you can do it for at C, beyond C, and that is called real because I can find it on a screen. If I can't find it on a screen, it is virtual. And for example, in a flat mirror, it's a virtual image behind the mirror. Between the focus and this concave mirror, it's virtual. In this particular one, it is inverted, beyond C, and larger. That's how we describe that particular. Now the formula, we call it the lens formula. It's also the one for the concave mirror. It's 1 over F is 1 over DO plus 1 over DI. DO is the distance from the object to the mirror, as shown. DI is the distance from the image of that you see to the mirror. And that works for a convex lens and also a concave formula, or concave mirror. The magnification formula, easy to memorize, easy. It's the height of the image over the height of the object, equals the distance to the image over the distance to the object. Interesting. You can find it by those horizontal distances. Just say hi-ho, Dido, and that'll tell you the magnification. A very important formula, easy marks. The velocity of a wave, universal wave equation. What is it? V is the frequency times the wavelength. F times lambda, frequency times wavelength. The definition of the index of refraction, what is it? N equals C over V. C, the speed of light in a vacuum, 3 times 10 to the 8th meters per second. V, the velocity in a different medium. The velocity changes. What is Snell's law of refraction? N1 theta 1 equals N2 sine theta 2. And here's everything is measured to a normal. Here's the incident ray, and there's the refracted ray if it enters a more dense region. N1 is the index of refraction of that first part. Theta 1, the angle. N2, and then theta 2, the refracted angle, notice to the normal. N1 sine theta 1, N2 sine theta 2. You need to know a critical angle. And here you're going from a more dense to a less dense region so that that refracted angle bends more away from the normal. And so that incident ray where it causes 90-degree refraction, look at it, is called the critical angle. There's the critical angle. And to find it, you set the refracted angle equal to 90 degrees. And it has to be going from a more dense to a less dense region. What is the index of refraction of air? 1. What is the one formula that summarizes all questions on index of refraction? This you must memorize. Sine theta 1 over sine theta 2 is N2 over N1. That's the index, Snell's law, which equals V1 over V2, the velocity in the first medium divided by the second, which equals lambda 1 over lambda 2. The frequency of the light does not change as it goes from air or vacuum into another medium, but the wavelength does change. Memorize that formula. Practice writing it out. Finally, in this review, what is the diffraction formula for a monochromatic wave going through 2 slits? Monochromatic, 1 color, 1 wavelength, 1 frequency. It passes through there, and we have distance d. Little d is the distance between the slits. L is the distance to the screen, which is huge compared to d. There's the screen. Now, distance y will be to the first fringe. I'm just drawing that dotted line as a reference. There's angle theta that we will label. Just practice drawing this out. Y tells you where the first bright fringe is. There's how I draw the first ray going through, the next diffracted ray, and if they interfere constructively, that means the bottom ray had to go a distance n lambda, 1 wavelength, 2 wavelengths, 3 wavelengths, 4 wavelengths, and I'll draw a little right angle like that. Now, that is theta, but then so is this right here in that angle. If you memorize this and look at that diagram, n lambda over d is sine theta. So d sine theta is n lambda. And if the sine theta is so tiny, it's the same as the tangent of theta, and therefore I can say the sine of theta is y over L. I can replace that for sine theta, and I can get this very useful formula for where the fringes are. Y tells you where the fringes are, the distance. N is 1, the first fringe. 2 is the second fringe. 3 is the third. Lambda is the wavelength, L the length, and D the distance.